All right, so we have allegedly inserted at least 2 rows into our cats table. How do we know that we actually have those values in there? Did something go wrong? Did we accidentally insert name into the age column and age into the name column? How do we verify that it worked as we wanted to? Well, one of the problems with a lot of programming from a teaching perspective is that there's no obvious order to teach things in. Things are very interconnected. I'm teaching you how to insert in this section, but we have to be able to know if our inserts work. So I have to show you a command from the next section, which is all about select. So the next section will dive a lot more into select, but for now, this is the most basic usage of select. Select star from some table name, in our case, cats. This just tells SQL, give me everything you have in the cats table. So let's try it. Select star from cats. And we see 2 cats. So we have name and age. They're properly set up, right? So the ages are inserted in age, the names are inserted into name, it's not reversed or anything, and we have 2. It's looking good. So of course we can do the same thing. Let's do it in the SQL Workbench this time. If I do select star from cats, this is commented out. So it looks like, I can even just delete it. But if I run this here, click the lightning bolt, we see the same values. It's a little different looking than it is over here, but it's the same thing, right? Blue Steel 5, Jenkins 7. Okay, so that's all you need to know about select for now, but there's a lot more that we will learn, and we'll write some very complicated selects later on. But again, this just says, give me everything from the cats table. Hey, welcome to the next section. So let's recap what we just saw in the last section. We basically saw how to make databases and then how to create tables which are currently empty, which are represented by this box here. Let's say this is a cats table. It's empty, it has no data in it. But in this section, I'm going to show you the tools to insert data into the cats table. Thank you, Blue. That was perfect. So we'll see how to do that. It's a insert command. So we'll see that and get lots of practice, lots of exercises inserting data into tables. And then the other thing we're going to see in this section, it's not the primary focus, but it's important, is selecting data back out. And I won't remove Blue from the box just yet. She's very paranoid. She loves this box. But the idea is, rather than deleting things, that's for another time, another section, how can we retrieve it out? How can we read it or search? So let's say insert, 10 cats into a box. And they all have different birthdays and breeds and names. I want to be able to run code like select or retrieve the last 5 cats added, or retrieve the names of the Russian blue cats, or retrieve the names of the oldest cat in your database, something like that. Wow, she's having a lot of fun in there. So that will be the goal in this section, is to show you those 2 commands, inserting data and then retrieving it back out. I'm just going to leave her in there. I can't stand to take her out. All right, well, I'll end it there. Blue's enjoying her box. I'm enjoying whatever this is. So we can create these tables that are completely empty, waiting for us to put data inside of them. Now let's talk about how we do that. How do we insert data? Well, the answer is we use an insert statement. It looks like this. We use the keyword insert and then into a table name. So for inserting into the cats table, insert into cats. And then we have parentheses and we specify the columns that we are inserting and in what order the data will be expected. So in other words, I'm going to say name is going to be first and then age. And then down here, which does not have to be on a second line, it's just to fit it into the slides nicely, we write values and then we have to follow that pattern. Name is right there, Jetson. Age comes afterwards, 7. So we put them both in parens. So this is a pair, in this case, a pair of columns, and then a pair of corresponding values. So here's some other ways of writing this, just so you are aware. You can do it in one line. You'll even see people space it out in some weird ways like this. It doesn't matter. As long as there's a semicolon at the end, MySQL knows where the end of the entire statement is. What really matters, though, is making sure you have the correct table name spelled correctly and that you pay attention to the order that you list the different values in. So I'm going to first insert from the command line. So let's see what database I'm working in. Okay, we're in the pet shop. Fine. Let's look at my cats table. And I think I dropped that table, didn't I? So I think I'm going to have to remake that table. So let's do create table cats, which will have very simple stuff. It's going to have name, again, is a varchar. This is basically a recap from previous videos. Age will be an int, and that should be it. Okay, so let's describe cats now. There we go, name and age. Let's insert a cat. So insert into cats. And then what am I going to insert into cats? Well, first I'll give you the name. Second, I'll give you the age. And then I can hit enter if I want, just to work on a second line, values. And then I have to have name and then age. So what should that name be? Let's insert one of my cats that I have at home. I've got a cat named Blue Steel. And I don't know her age, honestly. She's like 5 or 6 at this point. So let's just leave it at that. Hit enter with my semicolon, and I think it worked, right? It says 1 row affected, query okay. In the next video, we'll learn how to check our work, but let's insert one more row into our table. But this time I'm going to do it over in one of my graphical interfaces. So let's do it here in dbGate, although the process will be almost identical if you are working within SQL Workbench, MySQL Workbench. So all I'm going to do is make sure I'm working in the pet shop database. We can see there's a cats table there. I'll comment this out, and I'll just write insert into cats, and then name, and then age, values, and let's insert a different cat. How about, I don't know, Jenkins, the cat, who is 7 years old. So I'll run this entire file, execute it, and we get a response back, and it just says, yeah, that worked. Okay, so we trust that it worked. Until the next video, we'll take a look and make sure our values are in there. Next, we have a bit more to cover with basic inserts. First of all, I mentioned the order matters in the sense that if we tell MySQL that name is coming first in this first part of the insert, then we have to make sure name comes first. It doesn't know that, this is a name and this is an age unless we follow the order that we lay out. But we can switch that order. There's no rule that says we have to have name and then age. We could do age and then name. We just want to make sure that we follow that pattern. So if I try that, insert into cats, and then I'll say age first and then name, and then our values will be, and you can see I typed a quote because I was just not paying attention. We don't want a quote because we're inserting an age first. Let's say a 2-year-old cat named, how about Beth? Sure. And if I insert that, it looks like it worked. And if I do a select star from cats again, we'll see that Beth was inserted as the name in that row and age was 2. So as long as we follow the order we laid out, the order overall doesn't matter. It doesn't matter if age comes before name or name before age, as long as we are consistent with our values. Now, what happens if we are not consistent? What if I did insert into cats, and I say expect the name first and then the age, and then in my values, I get lazy or I don't pay attention, and I put the age first. We have 8, and then the name of Linus. Okay, what happens then? We get an error. We get an error that says incorrect integer value Linus for the column called age. You can't have an integer, which is what age is supposed to be, called Linus. That is not an integer, so it's telling me that. So what does that mean? If I look at cats, do we have Linus in here? No, we don't. So this error prevented the row from being inserted. Just be aware of that. These column data types are not guidelines. They are rules, at least with the way everything's set up right now. Age has to be an integer. There's no way to put a piece of text in there. So we tried that and we got slapped in the face. MySQL says not so fast. Okay, so that's a bit more about the order. The next thing I want to cover is a multiple insert. So we can insert multiple rows at once, which is a common operation. We don't have to have 3 separate insert into cats. I can do one insert into cats and then have multiple values, sets of values separated by commas. So let's try that. this time, maybe I'll do it from a file, just so we have a record of it. So I'll do insert into cats, name and then age. We don't have to do that order, but I will. And then values. And the first name that we'll do is, who should we do? This is the hardest part of the whole thing. How about a cat called Meatball? And Meatball's age is 5. And then I can add a comma and just have another pair. Let's do Turkey. And Turkey is 1. And one more. I guess we'll go with some food themed ones. How about Potato Face? Potato Face is 15. So one thing that you might see people do is format these so that all those all the parentheses line up. You really don't have to do that. It doesn't matter whatsoever, especially when we just have 3. Everyone can figure out what's happening here. But if you wanted to be consistent, you totally can. All right, so I'm going to run this, execute. Assuming I didn't put a semicolon there. Let's see, did it complain to me? It looked like it worked, so it may have figured out what I was trying to do. But let's verify over here. Select star from cats. Yeah, it did work. So if I had done that over here in the MySQL client, I left off a semicolon, well, we know what happens, right? Select star from cats. Nothing happens until I enter that semicolon to terminate the line. But over here, inside of dbgate, it can figure out, I guess it just has some logic to add that semicolon on. Who knows? Anyway, I should put it there because it's technically required. So that's how we can do a multiple insert. This is nice if you have, multiple rows you want to insert at once. You don't want to have a separate insert into for every single one. Instead, you can just chain them all together as long as they all follow the same pattern you laid out. Name and then age. Name, age, name, age, name, age. Okay, that's multi-inserts, and that's it for this video. All right, it's time for you to get a little bit of practice with what we've learned in the past few videos. I'd like you to make a table and insert some values into that table according to these instructions. Create a table called people. It should have 3 columns. First name is a piece of text or a string, 20 characters or fewer. Last name, same thing. And age is a number. I guess we all know age is only a number. Very funny. Really, though, age is just an integer here. Once you've done that, I'd like you to insert your first person. You don't have to follow these exact names if you don't want to type them out, but I'd like you to insert this person, Tina Belcher, who's 13. Bob Belcher is 42. And then do a multiple insert and get these 3 all in one go. And then you can just delete the whole table if you want. That's what I'm going to do. So I'm not going to bother making a new database. I'm just going to do it right here inside of my, what is this, pet shop? Sure. We're also selling humans from our pet shop. Okay, so go ahead and try this and pause. Please pause because I'm about to go over the solution and I hope you try it on your own first. So here we go. We're going to create a people table, first name, last name, and age. I guess I'll do this from the shell. So create table people. All right. And then let's do a couple spaces just to format it fancy. We'll do first underscore name is a varchar 20. And then last underscore name is the same thing, varchar 20. And then age is an int. I'll close my parens. Close the semicolon or add the semicolon. That looks good. Let's double check. Describe people. And that's good. First name varchar, last name varchar, age int. Now let's insert this first person. Tina Belcher is 13. So we'll do insert into people. And the order is just up to us, but let's say first name, last name, age. And then values, we'll have Tina Belcher 13. And let's verify, select star from people. Looks good. Tina Belcher 13, first name, last name, age. All right. So next up, we've got a second person. Bob Belcher is 42. So I'll do it again from the command line. Of course, you can do these from anywhere that you can run a MySQL query, but I'll do an insert. Honestly, well, sure, I'll just retype the whole thing, but I was going to say I can just recall this line and I might save myself some time, but it's all right. We'll do insert into people, first underscore name, last underscore name and age, values, and then we have Bob Belcher 42. Select star from people, and we see both of them. Great. So the last thing we'll do is our multi-insert, and I think I'll do this one from a file just to make it easier to type. So we've got Linda Belcher 45, and I'll speed this up so you don't have to watch me type the whole thing, but let's type the query. Select, why do I keep saying select? Insert into people, and let's do first name again, last name, age, and then our values. Now, I am going to have to refresh over here in the workbench so I see my people table show up. There it is. Okay, so we're working with Pet Shop, which has a people table, and the first person we're inserting is it Linda Belcher, I think? I don't remember her age. She is supposed to be 45. Okay, and then the next person, add a comma in there, Philip Frond, who's 38, and then we have one more person, which is Calvin, and I don't know how you spell fish odor, Fischoeder, who is 70, is that what it said? All right, close enough. And if I really wanted to be particular, I can line these up, it doesn't matter at all. Put my semicolon in there, execute the query, and do we know if it worked? Well, we don't get an error message. We get a check mark, which is good. It says 3 rows affected. That's also good. But I can do a select star from people. And now we see our 3 additions that we made in one go with one insert. And then the last thing I was going to do, which is not really in the instructions, is drop people. Drop table people. Goodbye. And all of our people are gone. If I try and select star, nothing happened. Well, it's not that nothing happened. We get an error because there are no people, or rather there is no people table. Okay, so that's our little exercise. Next up, we've got more to learn. Obviously, a lot left. In this video, we're going to answer one question. What is going on with this column right here when we showed a table's description? So if we take a look at our cats table, describe cats, this column right here, it says null, yes and yes. So field, that's the name of the column. Name is a varchar, 50 characters. Age is an integer. Null, yes, what does that mean? Well, what this means is that the null value is permitted in this particular column, in name and in age. Null is a value in MySQL that means no value. It represents the lack of a value for a given row. It basically means if we see null set to yes, that name can be empty for a row, or age can be empty, or in fact both could be missing entirely. In other words, it means the value is unknown. But it's really important to know this is different than something like 0. 0 is a number, it is a value. Null means that there is no information, there is no value at all. It's a MySQL concept here. So we could do something like this right now with our cats table. I could say I'm inserting a new cat that has a name and no age. I'll show you what happens. Insert into cats, name, and then values, and let's insert a cat called Todd. Okay, I hit enter, no problem whatsoever. Let's do a select star from cats, and what do we see? Todd is the name, that's what we expect. Age is null. So remember, it doesn't mean 0, it means no value at all, it means unknown. There's no information here for age for this row. And maybe sometimes I want that. It depends on the situation, because we might have, different columns that aren't always required that could be empty. But a lot of the time we want to require values to be present in a column, meaning you cannot have null. Just as a side note, right now we could do something like this. I can insert a completely empty cat, insert into cats, no values, just like this. I select star from cats, And now we've got this null cat, empty name, empty age. It's still a valid row, but it shouldn't be valid. I don't think we would want our cats table to permit this. So this is where we can add a constraint in called not null. Now, we could alter the table. We'll learn how to do that. But for now, what we're going to do is make a new table. I'll just call it cats2. Very simple naming pattern here. It's simple enough, but in the real world, you probably wouldn't want to have cats1, cats2, cats3, cats4. You probably just want a cats table that you are fixing and updating. But we don't know how to do that yet. So all we do is add on not null. When we are creating a table, for each column, we specify the name of the column, like age, the type, int, and then not null. Just like we could do primary key, that's another sort of add-on for a column. Not null is a constraint we can add. So let's try it. Let's make a new table, create table, cats2, and I'll open it up here. Oh no, I misspelled create. Let's just close that. We'll get an error, that's okay. Create table, cats2, and then we're going to have inside of here, let's go with name is a varchar. Let's limit it to 50 again, not null. Age is an int, also not null. Close the paren, semicolon, and now if we try to insert into cats2, let's just do name only, and then values. Let's insert Bilbo into cats2, we get an error. Field age doesn't have a default value. So that error might seem like a weird error you might not expect. Maybe you were expecting something like age must be present or an age cannot be null, but instead it says age doesn't have a default value. We'll learn how to set default values in a moment, but for now, if we take a look at cats2, it's totally empty. So it did not work. Now, if I recalled this and I did name and age, and I say that Bilbo is, 19, and then I select everything from cats2, it worked. So we can insert as normal unless we leave off one of those required fields or columns. So if I tried it the other way, right, if I didn't provide a name and I only provided an age, same thing, we get this error saying field name doesn't have a default value. Okay, so that's how we can add that constraint that says this column cannot be null. It must be present, and that's something we often want to enforce on important pieces of data. But not every single column needs to have not null, but a lot of them do. Oh, and the last thing I'll show you is that if we try and describe one of these tables again that has not null set up, we'll see null set to no for these different columns. So let's do describe cats. We see null is yes. Cats2, null is no. And in this case, it's just both columns have no or not null. Both cases allow null, but obviously we don't have to always have the same value for every single column. Okay, next we're going to tackle this default over here. Next up, we've got a quick aside. I want to talk about quotation marks. When we are working with text in MySQL, which we have been, right, with all the varchar columns, we provide those values inside of quotes. And technically in MySQL, depending on the mode that it's running in, you could use double quotes or single quotes, but that is not the case in other relational database management systems, aka other flavors of SQL. You don't want to use double quotes, you'll actually get errors. So it's a good practice to always use single quotes to wrap around whatever text we're providing when we're inserting or working with data. So let's make a really quick table. Let's call this shop. So create table shops, and it's just going to have a single thing in there called name, which is a varchar of, 100. Okay, looks like I have an error. Oh, I'm missing a second closing paren. So now I'm going to insert into this table, right? Insert into shops. We only have a name to insert, and the values will just be something like, shoe emporium, whatever. All right, so we would use single quotes around this text. Technically, I could use double quotes with the way that I'm running MySQL right now, but it's best to not do that to avoid any confusion, especially if you try writing SQL in any other SQL database flavor. So this will work. But what about if I have a quote within my piece of text, within my string. For example, we have something like Mario's Pizza. Well, this is going to be a problem because MySQL, just like any other programming language, if you've worked with them, is going to look for an opening quote and a closing quote, and it thinks this is the piece of text, and then it doesn't know what this is. So if I hit enter here, it first of all doesn't even acknowledge that I've hit enter because I had an opening quote, a closing quote, and then another opening quote. So it thinks this is all inside of a string. And in fact, right here, see how the cursor or the prompt has a quote there? That's MySQL's way of telling me I'm waiting for you to close the quote. So we don't want to do this. We have an error. It doesn't work. So what we need to do instead is escape that quote. And the way that we can escape a single quote, or I guess an apostrophe in this case, is to put a backslash in front of it. Now, MySQL will encounter that, and it realizes that's not actually going to be a quote that is terminating this piece of text. It's just a quote character inside this larger piece of text. So now if I do a select star from shops, we'll see that Mario's Pizza is correctly formatted. Now, I can also do the same thing for double quotes. If I needed double quotes inside of a piece of text, this is going to be a stupid example because there's no real reason to have double quotes here, but imagine I had a piece of text like, she said, ha ha. Well, if I have double quotes inside of single quotes, I don't have to escape anything. This is totally fine. Let's see what happens. Select star from shops. And those double quotes made it inside our piece of text. But if I did happen to be working with double quotes and then I wanted a double quote inside, I could escape that double quote character, but I don't think it's even worth showing you because, as you'll recall, a couple minutes ago, I talked about how you want to use single quotes on the outside always in MySQL, even if you can get away with double quotes sometimes. Just stick with single quotes to be consistent and you won't have to worry about it. And then if you need to escape single quotes, use the backslash single quote character. And if you need to, you could put double quotes inside of single quotes. There's no problem with that. That's just considered regular text. We can do whatever we want in here. It's just when we start and end a string that we have to pay special attention. Okay, not the most exciting topic, but something that we have to get out of the way. So that's it. Use single quotes. That's all you should remember. Okay. All right, next we're going to talk about default values. As we saw when I describe any of our tables so far, describe cats, cats2, we have this default column here that describes the default values present for a column. It's kind of a confusing sentence, but essentially there is no default value for name or age. Same thing with cats2, there's no default value. But we can change that. When we create a table, we can specify a default value using this syntax. Default, and then immediately after, separated by a space, whatever the default value is that we want to set. Now, we can alter a table as well to do this after the fact, but we haven't covered that yet. So once again, we're going to make a new table. This time, cats3. It's going to get a little confusing, cats2, cats3, but we've only got one or two more. So let's do cats3. And I'm going to just keep it simple. Again, name, varchar. We'll have a default of unnamed or no name or unknown, whatever it would make sense to set up as a default value for a cat. Let's say we're running a shelter and we bring in cats off the street. They don't have microchips or collars. We don't know their name. We probably still assign them some name. I think the way shelters usually do it is they actually have a list of different random names they can pick from instead of naming every cat that comes in, John Doe or something. But it doesn't matter. That's not the point of this course. But let's do a create table, cats3, and we'll have name, which again will be varchar. In the slides I did 100. It doesn't really matter. We're going to have short cat names, so I'll do 50. And then default, let's go with mystery. Okay. And then age is an int. We don't have to provide a default value if we don't want to, but in this case, just to demonstrate it, I will. Age, int, the default value will be 99, just like the slide. All right. Close my paren, semicolon, and we're done. So now what I can do is insert into cats3. Let's say I only provide an age because this cat that we just picked up off the street, this poor, wet, sad cat, we don't know its name. So we can estimate its age, I guess. We'll say its age is 2. If we look at cats3, select star from cats3, we'll see that name has been set to mystery. So that default value kicked in. In fact, I could insert a cat that has nothing when we created, no values present, but because we have those default values present, we end up with mystery and 99. Now it's kind of confusing to have all these cats called mystery, and why on earth would the default age be 99? It doesn't matter. Stop asking questions. So that's how we set up a default value, at least when we create a table. That's how we set up a default value. Following the name of the column, we then specify the data type, and then add-ons like not null, or in this case, default, followed by the default value. Now, something that you might be wondering is, do we need to specify not null and default? Because by providing a default value, doesn't that mean that there's no way for this value to be null, right? If I inserted this empty cat, as we saw right here, and we select star again from cats 3, we don't end up with null values because we have default values. However, that doesn't stop me from changing this to be null or changing this to be null. Just setting a default value is not the same as saying this can never be null. So they can work in tandem. Not null just says this can never be empty. This particular column, this value can't be empty. And default is simply saying if there is no value specified, it should default to this value. But if we had default without not null, then I could easily set a value to be null manually. So I can do that right here. I'll show you. I can insert the value null directly into a table. So insert into cats 3. Let's say name and age. Values will be null and null. So it's a special MySQL value. And then I'll select all my cats. And what do we see? Null and null. So that tells us that a default value is not going to protect us in a situation like that if I manually set something to null, which is not always a bad thing. Sometimes we want to allow null. Imagine we're setting up a phone book or a contact app or something where users have to have or every row in the users table has a name, an email, a cell phone, and maybe a home phone number, maybe a fax number. But not everybody has those. So maybe we make cell phone a requirement or home phone a requirement, but we can make the others nullable. They don't have to be present. So we could say your fax number can be null. If you don't have a fax machine, I don't have one, we would allow that to be null. So null is not a bad thing, but it can be a bad thing if you aren't expecting it or you don't want to allow it. But all you have to do to make sure that a value is not nullable and has a default value if it's not present is to use both, not null followed by default. So to save time, I'll just copy and paste this so that you don't have to watch me type the whole thing. I'll paste it in there. And now if I were to try to insert into cats 4, where I manually write null as my two values, I'll get an error. It says name cannot be null. And it would have said age cannot be null, but it stopped at that first error. So it didn't insert anything. But if I instead did this, insert into cats 4, empty, empty, we will get those default values. So I know this is kind of boring. I hope I was at least clear here so you understand the difference. Cats 4, we have unnamed and 99. Those were the default values. And if I go do a describe cats 4, not only do we see that it's not nullable, name and age, neither of which are nullable, we also see the default values listed. So if you ever forget what the default value is, you can describe your table and MySQL will show you right there. Okay, I hope you're hanging in there. This has been a bit of a long section, but we've got one more topic to cover around creating tables, inserting data, constraints. We're going to talk about this key portion that we see printed out. Currently, it's empty when we describe one of our tables. So I described cats 4 or any of our tables so far. Key just has nothing there. So what is this key thing? Well, right now with our table, I could insert rows that are identical to one another. In fact, I could do that very easily, right? If I just insert empty cats, we get those default values. So now if I select star from cats 4, we have a whole bunch of rows that are completely identical. And maybe that's fine to have cats that have the same name and the same age, but it makes it really hard to work with these rows and distinguish them from one another. It's just really a challenge. In the real world, if we had data that looks like this, we would make sure we added on some sort of unique identifier. And this is a really common thing to do in the world of SQL, not just MySQL, but pretty much all of SQL, not pretty much. All of SQL, definitely all of SQL. We add unique IDs to rows so that we can differentiate them even when all the other data looks the same. So this is something we'll do for almost every single table you ever make, is add some form of a unique identifier. So in our case, we could do something very simple, just add a numeric ID that starts at 1 and then goes to 2, 3, and 4. And this is a really common thing to do, not just to have a unique ID, but to just have it be an integer that starts at 1 and then goes up by 1 for each row. So this way, even if we all have, every row is Monty, Tabby, 10, they're still guaranteed to be unique as long as the cat ID is unique. So there's a couple ways of doing this. One is, I guess, just make this column and say it's a number, but that doesn't necessarily require it to be unique. If I just made an integer column, well, what would stop me from adding 1 and then 1 and then 1 and then 1 in the same way that all the ages can be set to 10? We don't want to do that. Instead, we're going to declare a column, the ID column, the primary key for this table. So a primary key is a fancy way of saying a unique identifier. We'll talk about something called foreign keys later. So key is a term in the world of SQL. Primary key is going to be some column that's used as a unique identifier for each individual row. So they have to be unique within the table. So when we define a table, we can add on the primary key constraint to some column, usually an ID column. So here I have a cat ID, which honestly I'd probably just call ID. We know that it's in the cats table, but just to make it clearer here, I called it cat ID. It's a number. It can't be null. Now we're going to come back to this not null thing in a moment. And it's a primary key. So that tells MySQL it's not only required, but it has to be unique. So if I just copy and paste this and put it in my terminal here, first of all, if I do a describe the table, which I called unique cats, we'll see that key is set to pri for primary for cat ID. So what this means is that it has to be there, it has to be unique. If I try and insert into unique cats and I insert cat ID, name, and then age, values, we have, I don't know, we'll start with 1, and then name can be bingo, age can be 2. We insert that, it works great, as far as we can tell. Now, if I recall that line, and I try and do the same thing, but this time my cat that I'm inserting is called Bongo, and Bongo is 3, but I leave 1 as my cat ID, I get an error. It says duplicate entry 1 for this key, this unique primary key. You can't do that. If I do a select star from unique cats, we don't see that second row we tried to insert. So we have to have that unique value. I could then go back and say, all right, values 2 will be my cat ID. Now this is kind of annoying, right? To have to keep going and manually adding in some unique number. There's nothing stopping me, by the way, from just jumping to 999 or negative 99. It's not a constraint that says this thing has to go up by 1. Instead, it just says it's a primary key, it has to be unique, and it has to be a number because we said it was an integer. Anyway, I think I will stop here. We have a bit more to talk about with primary keys in the next video, but I want to keep you sane and keep your hair not pulled out of your head. So I'll split it, and I'll see you in a second. I don't know if it makes a difference. I don't think so. Okay, I'll keep this brief. We've got a little bit more with primary keys. As we saw in the previous video, when we define a table, when we create it, we can specify the column that we want to be a primary key by specifying primary key right after the column name and the data type and other constraints. But there's another way of doing this, another syntax that you'll see, and it looks like this. We can create our column cat ID, it's an integer, it can't be null, and then later on we can come back and say, hey, remember that cat ID? Make it a primary key. These will both do the same thing, it's just a different syntax. I actually tend to prefer this one here However, this one is a little long for slides, or horizontally long at least. So I'll often in the slides resort to this just to keep things a bit more compact so that I can make the text larger. But you'll see both of them in the world. You should know that they both exist. Primary key and then a column name, in our case cat ID, is the same as calling it a primary key when we initially set it up. The next thing I want to talk about is not null. It is technically redundant to specify a column as a primary key and as not null, because primary keys can never be null. That's just how they work. If I copy and paste this one, well, it's called unique cats. I already have unique cats, don't I? Let's drop our table, unique cats, goodbye, and remake it. This time, cat ID is simply an integer. It doesn't say not null, but I do make it a primary key. If I try and insert into unique cats, and I do a cat ID, a name, and an age. Let's just start with a regular cat that meets those requirements. Cat ID is 1, name, I'll just go to Oingo this time. Age is 2. I insert that cat, no problem. But let's say that I leave off this primary key, cat ID. It doesn't say not null, but it is a primary key. That means it's required. And if I hit enter, well, I get an error this time because I told SQL I was going to provide a cat ID and I didn't. So let me fix that. I'm not going to provide a cat ID, as if I was expecting it to allow me to insert it without an ID. But we have a problem. It says cat ID doesn't have a default value. And that's the same error we saw when we set up not null, but we didn't set up not null. We set up a primary key. If I describe my cats table though, or my unique cats table, we do see that it cannot be null. So I didn't say that. I just said it was a primary key, but it's redundant to specify not null because that primary key constraint requires that value to be present alongside being unique. The final thing and most useful thing that I'm going to show you, I think, in this video is setting up auto increment on your primary key fields. So there's a special thing, auto_increment. It's easy to forget the underscore because we have primary space key, but it is auto_increment. Is going to make a column automatically increment starting at 1. You can change that, but it doesn't really matter for us. We'll have 1 and then 2 and then 3 and then 4, and we don't have to go and add anything. We don't have to manually insert and keep track of the unique IDs. We can just rely on the auto increment. So let's go ahead and copy this and paste it in. And is it also called unique cats? All right, this one is unique cats 3. Terrible name. But if we do that, I can now insert into unique cats 3. And I don't have to specify a cat ID. I simply need name and age. And technically I don't need any of those actually because they're not required. They could be null, but let's add them in. So name will be Boingo and age will be 1 for this first cat. Let's take a look. Select star from unique cats 3. And we see that cat ID was automatically assigned and it's set to 1. Now, if I insert another cat, I can actually just insert the exact same cat in terms of name and age and keep doing that. And every single row that I insert here will have its own unique cat ID because I set up that auto increment. So from unique cats 3, select everything. They all look the same, Boingo 1, but cat ID automatically incremented for each one of them. So this is really useful because now I have this primary key that doesn't require any effort on my part to be unique. I don't have to keep track of a number and add 1 or anything like that. I just insert a value and we automatically get that unique ID. So that's super common to do. We combine auto increment with primary key all the time. And you can do it on the same line. Just want to be clear about that. If I copied this, let's say I'm doing it from a script like over here in a file, I can do this. Auto increment primary key. It doesn't have to be on separate lines. And let's call this unique cats 4, which is annoying, but let's just call it that. And run this script. I've got an extra comma here, so it's going to complain to me. Make sure I'm in the pet shop database. All right. And how do I run you here? I need to click lightning bolt. let's describe unique cats4, and you'll see that we have that primary key, we have auto increment set up, and if I were to insert a cat, insert into unique cats4 values, let's say I'm inserting nothing. It's just going to be empty. I'll do it a couple of times. And then I select everything from my unique cats4. We see cat ID did work. It's a primary key. It automatically increments 1, 2, 3, and so on. And the last thing I should mention is when you set up the auto increment, if I did try and insert a cat that manually had a cat ID that was already in use, like insert into unique cats4, let's say I'm adding the cat ID myself, which you normally wouldn't do if you have auto increment set up. But if I wanted to, a cat that has the ID of 3, I'm going to get an error because there's already a cat in there with cat ID of 3. Just because we have auto increment doesn't mean that the regular sort of primary key constraint goes away. It still has to be unique, even if I'm not the one usually making this number, right? I'm relying on the auto increment capability. If I try to insert a duplicate value, I'll get an error and it won't insert. Okay, so that's primary key and auto increment. You'll see them together all the time. All right, it's now your turn to get a little practice creating tables and working with column constraints. So I'd like you to define a table called employees, and it should have the following columns: ID, last name, first name, middle name, age, and current status. So ID should be a primary key, it should be an integer, and it should automatically increment. Last name, first name, and middle name are all text, but last name and first name are mandatory, they're required, and middle name is not required. Not everybody has a middle name. Additionally, all these text columns that you see here, I didn't specify a size, but let's just say 100 characters for last name, first name, middle name, and current status. And then we have age. Age is also a number. We only know integer, so it's an integer for now, and it is required. And then current status would be, if the employee is currently employed by us, if they are a contractor, if they have been let go, if they're on, paid leave or something. But it is text. It is required. It's mandatory. It cannot be null. But it will have a default value of employed. Okay? So try making this and pause the video, please, so that you do it. And then I'll be back in 3, 2, 1 with a solution. Here we go. So we're going to define a table. I think I'm going to do this all in a file using one of my GUIs, like SQL Workbench. So I'm going to do a create table, employees, and I know that we have ID in here, and ID is going to be an integer, and I know that I want it to auto increment, so I can add that in. Just remember, it's auto underscore increment. And then I have to decide how I'm going to make it a primary key. Am I going to do this, which is fine, and that's probably what I prefer, or am I going to do it after the fact, like this, primary key, ID. I think it's better, in my opinion, just to do it when I'm creating and defining the column, so primary key. Remember, there's an underscore for auto increment. Primary key, though, there is not. Okay, then we have last name, first name, and middle name, all of which are varchars. They're text. So let's start with last name, varchar, and I said 100, I believe, but all that matters is that you pick some value that's consistent. I mean, I guess that's not all that matters. We don't want you to pick 5 characters, but we'll do last name, first name, middle name, just like that. Put my commas in there. But then we know that last name and first name are required, so we'll put in not null. Same thing here, not null. And then we have age, which is a required number. So age is an int, and it's also not null. And then finally, we have current status. So current status, which is a varchar 100. And it cannot be null. It's mandatory. So not null. And we have a default value of employed, right? make sure, employed. Yep. Okay, so I think that should be it. We can always run this entire script, or I guess you could just copy and paste it over in your terminal, however you want to do this. I'm doing it on the pet shop database still. It doesn't matter because I'm going to drop the table at the end of this video. But let's make sure that it works. And also, here's my solution in the slide. I guess we should compare and make sure I didn't miss anything when typing this out. A semicolon, we should put that in there. But otherwise, it's the same, right? Current status, varchar 100 not null, default employed, primary key, auto increment, all that stuff is there. So we should be good. Let's just run this script. So in Workbench, in SQL Workbench or MySQL Workbench, I can run the entire script by clicking the lightning bolt. This entire file will run. Or if I have my cursor in some part of a single query or a single sort of unit of SQL, right, one command, what we'd call a query, I can use this other version here right next to the lightning bolt that will only run wherever my cursor is. So it doesn't matter because I have all this commented out anyway. But if I do want to do that, I'll run it there. We get a green check mark. Nothing went wrong as far as we can tell. I could always just refresh over here. I should have an employees table now. And if I look at it, I can see my values down here. But I'm going to head to my terminal, and I'm going to do a describe employees. And I'm too zoomed in for the size of this table. There we go. I zoomed out a bit, and now we can see all the different columns, their types, just int and varchars, and then if they can be null or not, and what our primary key is, and what the default values are, if there are any. And then lastly, auto increment. Okay, so let's try and just insert an employee. This is not part of the requirements at all for this exercise, but let's insert a new employee. So insert into employees, and let's say that I'm not going to insert the ID, right? We have auto increment, so no need to do that, but I'll do first name and last name and age, because those are the only ones required, right? First, last, and age. Current status has a default, so I'll rely on that default value. So then I'll do values here, and his name is Chicken Man, and that's his last name, obviously, and his age is 87. Thomas Chicken Man. All right, let's select star from employees and make sure we see current status has a default value of employed. Middle name is null because that's totally fine. That means this person doesn't have a middle name. Again, null is not always bad, or it's not necessarily bad. It's just a concept of no value. And many people will have no middle name, right? So we don't want to make it required. We don't want to have a default. I guess we could put a default in there, but why bother if null serves the purpose we need? Okay, let's just make sure that if I try and insert somebody, let's say missing an age, that we're going to have a problem. So let's get rid of age there, and then it's duplicated. That's fine. We'll have two Thomas Chicken Mans. But we get an error anyway saying age doesn't have a default value. You can't insert that. So it's working. Our auto increment is working. If I just insert another identical employee a couple of times, we should see, if I select star from employees, that we have ID of 1, 2, and then 3. Okay, so that's our little exercise for creating a table with all those different constraints, those little add-ons we saw. Auto increment, primary key, not null, and default. We use those all the time.